Hi, in this video, I will do examples with zeros of polynomials. So we skipped section 3.2. We went from section 3.1 to 3.3. And what we're going to do is write a polynomial function with the given conditions in standard form. So these are on page 337. We are going to find a polynomial function of degree 3 with real coefficients that satisfy the given conditions. In this problem number 54, the polynomial has zeros at 1, -1, and 0, and f of 2 is equal to 3. So far, for now, we're going to call the leading coefficient A. We're going to use this condition f of 2 equals 3 to find the leading coefficient. But if 1, -1, and 0 are the zeros, we know that the factors are x minus 0, simply x, x minus 1, and x plus 1. So from the zeros, we can determine the factors. And then x minus 0 is the same as x. So we have a times x, and then x minus 1 times x plus 1 is a product of a sum and a difference. So that's x squared minus 1. And then we're going to distribute the, or actually we can use the initial condition to find A. So we're not done yet, but we're going to use f of 2 equals 3 to find A. That is a times 2 times 2 squared minus 1. So that's a minus 1. That is equal to 3. 2 squared minus 1 is 2 squared minus 1 is 3 because 2 squared is 4. So that's 4 minus 1 equals 3. 4 minus 1 is 3. So we have 2 times A is 2A times 3 equals 3. These two cancel. And we have that 2A equals 1. Or A equals 1/2. So now we have more information. We know that f of x is 1/2 times x squared minus 1. And the final answer must be a polynomial in standard form. So that's in factor form or sort of. So the final answer is going to be f of x. Let's distribute the x. So that's going to be 1/2 x cubed minus 1/2 x. So that's the polynomial function. That's the polynomial of third degree with the given conditions. I'll do a similar example. That's number 58. Same question. We're going to find a polynomial function of third degree having leading coefficients that satisfy the given conditions. That's a polynomial with a 0 of 2 and a 0 of 4 having multiplicity 2 with the condition that f of 1 equals -18. So far, we know that f of x is going to be some leading coefficient x, some leading coefficient a. Then a 0 of 2. If 2 is a 0, then x minus 2 is a factor. And if 4 is a 0, then x minus 4 is a factor. But we also know that this has multiplicity 2, so that's going to be x minus 4 squared. And we're going to use that condition f of 1 equals -18 to find A. Okay, so let's plug it in. A times 1 minus 2 times 1 minus 4 squared equals -18. So 1 minus 2 is -1. And 1 minus 4 squared, that's -3 squared. Where -3 squared, this is 9. 9 times -1 is -9. And negative, or the opposite of 9a is -18. So A, it's negative 18 over negative 9, or simply 2. Okay, so now we have the polynomial function, f of x. It's 2 times x minus 2 times x minus 4 squared. And this answer is already correct. Only problem is that the polynomial is in factor form. And we want a polynomial in standard form. That is, we don't want any factors. So we are going to we're going to distribute x minus 2. X minus 4 squared, that's the square of a binomial, so that's x squared minus 8x plus 16. And what we're going to do, we can distribute the 2. And then we're going to distribute the 2x minus 4. That is 2x times x squared minus 8x plus 16. So 2x times x squared is 2x cubed. 2x times minus 8x is minus 16x squared. And 2x times 16 is 32x. And then distribute the 4, that's minus 4 times x squared. A negative 4 times minus 8x, that's 32x. And negative 4 times 16 is negative 64. So this is still f of x. And finally, we're going to combine like terms to write the final answer. So f of x, so final answer, we have 2x squared, or 2x cubed. Then minus 16x squared minus 4x squared, that's going to be minus 20x squared. 32x plus 32x is 64x minus 64. And this is the final answer. So the factor form is correct, but my MATLAB is, unfortunately, my MATLAB is not going to accept it. So you need to keep it in this form. And I'll do 3 other examples, or 2 other examples about writing a polynomial with the given conditions. Not necessarily polynomials of third degree. So I'm copying the directions. We are going to find a polynomial function of least degree, having only real coefficients and zeros as given, assume multiplicity 1, unless otherwise stated. So if they don't tell you the multiplicity of the 0, it's safe to assume that the 0 has multiplicity 1. So we're going to do number 64 on the same page. So this polynomial has zeros at 0, minus I, and 2 plus I. So one of the things about complex zeros when the polynomial has real coefficients is that if a complex number is a 0, then the conjugate of that complex number is also a 0. So with that in mind, I and 2 minus I are also zeros. And it doesn't say anything about the leading coefficient. So if it doesn't tell you any other condition, it's safe to assume that the leading coefficient is 1. So we have some information. We know that f of x is going to be x. That is, x minus 0 is a factor, x plus I is a factor, and x minus I is a factor. And x minus 2 plus I is a factor, and x minus 2 minus I is also a factor. So that's the polynomial in factor form. Unfortunately, my MATLAB is not going to accept the answer like this. It must be a polynomial with having only real coefficients. Okay, so we have x. Then x minus I times x plus I. This is the product of a sum and a difference. So this is x squared minus I squared. If you remember the section about complex numbers, I squared is going to be -1. And then I'm going to rewrite this a little bit. So that's x minus 2 plus I. That's the same as x minus 2 minus I. So the opposite of I is going to be minus I. And then we have x minus 2 plus I. The reason to do this is to get rid of the i's. So I squared is -1. And I know that x. So the opposite of -1 is going to be +1. And this is what I'm going to do. This is the reason why I rewrote it. I'm going to treat this as the product of a sum and a difference. So that's going to be x minus 2 squared. And then minus I squared. Where I squared is -1. So minus minus is plus. And I have x squared plus 1. And then I have the square of this binomial. The square of x minus 2 is x squared minus 4x plus 4. And then minus -1 is going to be +1. Okay, so I'm going to distribute the x in front. And I'm going to combine the +4 and +1. And finally, I'm going to distribute the x cubed and the x to have the polynomial in standard form. So far, my MATLAB doesn't accept the answer like this. So let's distribute x cubed. So x cubed times x squared. X cubed times minus 4x. And x cubed times 5. Then x times x squared. X times minus 4x. And x times 5. And finally, combine like terms. And we have the polynomial that we were looking for. F of x. So the only terms I can combine are the ones with x cubed. 5x cubed plus x cubed is going to be 6x cubed. So this is the final answer. So that's the only answer that my MATLAB will accept. And the last example is number 72. Same question, we need to find a polynomial having only real coefficients with the given conditions. Number 72. Okay. So this polynomial has zeros at 2 plus square root of 3, 2 minus square root of 3, and 2 plus 3i. So if 2 plus 3i is a complex zero, then 2 minus 3i is also a zero. So I'm ready to write a polynomial in factor form. They don't tell us anything. They don't give us any initial condition like in the first two examples. So it is safe to assume that the leading coefficient is 1. And so far we have that this is in factor form. This is x minus 2 plus square root of 3. times x minus 2 minus square root of 3 times x minus 2 plus 3i times x minus 2 minus 3i. So we need to get rid of those square roots and those i's, those terms with I. So what I'm going to do is rewrite these terms, or I'm going to rewrite these factors. I'm going to distribute the minus, so I have x minus 2 minus square root of 3 times x minus 2 plus square root of 3 times x minus 2 minus 3i and x minus 2 plus 3i. And I'm going to distribute by pairs. So we are going to multiply the first pair as the product of a sum and a difference, and I have, this is x minus 2 squared minus square root of 3 squared, where the square root and the second power cancel. They undo each other or cancel. And the second product, we're going to treat this as a product of a sum and a difference. So this is x minus 2 squared minus 3i squared. So we're going to square the binomial, x minus 2 squared. This is this x squared minus 4x plus 4. And then the square root of 3 squared is 3. And then x minus 2 squared, that's x squared plus 4x plus 4. That was actually a minus. That's minus 4x. Plus 4. And then 3i squared, this is 9i squared, where I squared is negative 1. So we got rid of the square roots and the terms with I. We can combine like terms, the 4 and the minus 3. And then I squared is negative 1, so 9i squared is negative 9. The opposite of that is plus 9. So combine like terms. So this is starting to look better. Still is not the polynomial that we're looking for. So the last step is to distribute. We can distribute the first polynomial and fix the second one. So this is still f of x. Okay, x squared times x squared minus 4x minus 13 is x squared times x squared. Then x squared times minus 4x. And x squared times 30. Then distribute the minus 4x. Minus 4x times x squared. This is 4x cubed. Minus 4x times minus 4x. And x squared times, or minus 4x times 13. And finally, distribute the 1. That should be easy. 1 times whatever is itself. So that's x squared minus 4x plus 13. And finally, we're going to combine like terms to write the final answer. So we have x to the power of 4. And then the terms with x cubed are I have 2 minus 4x cubed. With x squared, I have 13x squared, 16x squared, and x squared. So 13 plus 16 plus 1 is 30. 50, negative 52 minus 4 is negative 56. And I finally have a 13. So this is the final answer. And thank you for listening.